Hello friends, my name is Nadav Benedek and today we'll be talking about ChatGPT, the generative model. You probably heard about it in the last few weeks and few days, the beautiful word that was made by OpenAI. And today I want to explain how this whole thing works. What are the models? How do you train the ChatGPT? And it's going to be very high level just to get a general understanding of how it works. So basically, there are three main steps. The first step that is being done in GPT is basically start with the GPT-3. Okay, so we have the GPT-3 model, 3 or 3.5. Basically, it's a model, it's a neural network, transformer based, and I can explain in other videos how transformer works. Basically, this model takes some input, which is a string, a text, a question, or just random text, and generate a new sequence of text. And this model was trained on publicly available data. It could be the internet crawl, Wikipedia, books. You can train it on every kind of data that you want. And basically, this is like a language model, which means that it can create text which is reasonable, grammatically correct, etc. So that's where you start. You take this model, the G model here, and then what you do is basically you want to improve it to make it better for answering questions or communicating with a human being. Because when you, for example, create a language model out of Wikipedia, it can create text, but not necessarily the text that you instruct the model to do. So what you do basically is you do what's called supervised fine tuning of the model. Okay, and you take human labelers. In this case, it was around 40 people that took questions. We call them also prompts. And let's say for every prompt, they made an answer, which is human crafted and we can call professional answer. They did it for various kind of texts. For example, you have here another person answered a question, he wrote it down, and like that you can do it as many times as you want. And then you take all these supervised data set and you train the GPT model using these texts. Okay, you take this G model and you make an SFT model, which is exactly the same model, just that you want to have pre-trained results, which makes it more fit to answer, for example, questions. So first, this was step, let's say number one. That's where your step, let's call it 0, because you start with it and then you do the SFT, which makes the model better. And then you want to create a way that can determine how good is an answer, right? So you want, because let's say right here, let's say all these examples that the human labeler trained, let's say you have only a few of them, right? Let's say you have only 100,000. You want to generalize it. If you give a prompt and a response to make score how good is it. So what we do right here, we train what's called a reward model, okay? And the reward model is, again, a neural network, almost the same architecture, that basically takes two inputs, not one, takes an input or a prompt and a response, right? And then tries to find a number, a score, that says how good is the answer Y to the question or to the prompt X? Okay, and that's S. And how do you train this kind of model? So again, you take all these people for labeling, and you pick random prompts. For example, let's say you choose, let's say, 1,000 or more prompts. Actually, they can do much more. And then for each prompt, let's say we take one of them. Okay, we generate using the SFT model. We generate 8, for example, it can be 4 responses, right? So we have all these, and we want to see, we have 8 responses, and we want these people to rank which one is the best answer, okay? So for example, let's say we have 8, so they say that, for example, Y4, answer 4 is better than Y6. They say that Y7 is less than Y1. Okay, so if we have, let's say, 8 responses, okay, so we are going to have we're going to have this much comparisons, right? So if it's 8 and we have, let's say, we pick 2 out of 8, so basically we have 8 multiplied by 7 divided by 2 responses. So in this case, it's 28, okay? So when a human labeler gets 8 responses, he needs to make 28 decisions, basically. And that's the data set that we have for the reward model. Okay, and now let's see how we train this model based on all these results that he got. Okay, so what we do, so we have the reward model, and the reward model, how do we train that? Okay, so we have, it's like a neural network, right? We have an input, and we take two different responses, okay? And then we get a score from the model for each one of them. So that's the output of the model, and we know the real result because we have the human labeler that ranked that. And so we know, for example, if S1 is better than S2, okay? And this way we can create a loss function, and using that loss function, using gradient descent, we can make the reward model better, okay? And the loss function, it basically look something like that. Let me write it quickly. So we're going to minus, we want to make it a loss function. So we normalize it, and basically we sample from the different prompts that we have, and essentially it's the log of the reward of the winning response, the one that the labeler ranked as the good one, to the losing response, okay? So when we have this kind of loss function, basically, right? So loss function wants to be minimized, so this should be increased, right? This part should be increased because we have the minus here. And so what happens is that the reward of the winning goes up, and the reward of YL, which is the losing, goes down, right? So it's the same network, same parameters here and here. And using the gradient descent, we make it more accurate, basically. We train the reward model to get any two kinds of prompts and output a scalar value, which correlates to the quality of the response. Okay, so that's basically the reward model. And what we do with the reward model, basically, we now use reinforcement learning to improve again the network that we did. So let's see what we did so far. So remember, we had the GPT as a starting point, already trained, we don't need to do it again. Then we did the supervised fine-tuning, okay? Then we trained the reward model. And now we're going to use the reward model to further improve our model, the SFT model, using reinforcement learning. Okay, and how are we going to do that? Pretty simple. Again, we're going to pick in random prompts, right? So we have SFT getting a prompt, okay? And in reinforcement learning, it's called action. And the action will be the regular output text of this model, right? And then we're going to take it to the reward model. Remember, it gets prompt and the answer, right? This is the prompt. This is the answer. And it gives back the reward, which is basically, this is the environment of the reinforcement learning. And then basically we make our model, this one, even better, because it takes text, a prompt, output what it thinks to be the best answer, get a feedback. If it's good, not good, should be improved. And then the model using reinforcement learning gets better. And what they did is basically use a technique in reinforcement. There are many ways to use reinforcement learning. One of them is called PPO, which I'm not going to today dive into in this talk, but you do the PPO training to make the SFT better, and that's it basically. And then you get the ChatGPT. So you have these 3 steps. You start with the GPT, you do the supervised learning using human labelers, you train the reward model based on the SFT, and then you do reward model that improves the SFT using the reward from the reward model. That's about it for this talk. I hope you enjoyed it.